Okay, in question 1, we're told the velocity is 32t minus 3t squared, where t is time. If you get an equation like this is one where you have variable acceleration, and that means you use calculus. You means differentiation and integration in this question, not the Suvat equations. So in part A, you've got to find the distance AB. That's the distance that is done in the first 5 seconds. For distance, the formula you should have is you integrate velocity. So in this question, to find the distance travelled, we need to integrate 32t minus 3t squared with respect to t. And we actually put two numbers on here, two limits. We're trying to find out what the distance is between time of 0 seconds and a time of 5 seconds. So we put those limits in there. When we're integrating, we add 1 to the power and divide by the new power. Add 1 to the power, divide by the new power. We use the square brackets because we have limits here. We don't need to put a plus c in, so we get this. We can then do some cancelling. It's 16t squared minus t cubed between 5 and 0. That means we substitute in a 5 for every t, and then we substitute in a 0 for every t. Okay, when we do that here, we will get 275 if you work that out. We'll get 0 over there, so the distance is going to be 275 metres. Part B of the question, you are asked to find the acceleration. Again, it's one of these variable acceleration questions with differentiating or integrating, and acceleration is how velocity changes over time. So that's dv dt. So what we need to do now is we need to differentiate this. Differentiating is where the power drops down. If you differentiate that, you will get 32 take away 6t. We have to do this when t is equal to 3. So when t is equal to 3, this will be 32 take away 6 lots of 3, 32 take away 18, which is 14 meters per second squared.